Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you learn wherever you go. I'm your host, Zach Menace, for this episode of Net Plus, TCP IP Model Part 2. Hopefully you saw Part 1. And Wes Bryan is here to take us through it. Wes, good to see you again, sir.
Hey, Zach, thanks for having me back. That's right. Talked a lot in that first part, and we could have probably made it a really long episode, but we decided, hey, why don't we just go ahead and break it up, and we'll come back and kind of show you a short episode here to just tie off the loose ends, because in the first part, we really just described everything about, a lot about transmission control protocol, internet protocol suite. And I know I keep saying that, but again, the more you hear that acronym, hopefully the more it'll sit in. But that's the TCP IP model, right? And we talked about the different layers and what you can see on the different layers, right? We talked about things like, well, hey, network interface layer, right? It defines what am I using copper media? Am I using fiber optic media or copper media? Zach's over here saying, you got it backwards, man. Thanks, man, I appreciate it. Right, what is the media that we're using, right? Or what is the medium we're using, right? And if we're using wired networks, right, we're going to be using, some kind of switch, right? It's going to use that carrier sense, multiple access, collision detection. If we happen to be using one of these guys here, wireless access point, then we're going to be using 802.11 standards, right, versus the 802.3 standards. All of this information, and even the media access methods, right, here in wireless, right, carrier sense, multiple access, collision avoidance, all of that is defined in that network interface layer. Remember, we also started to move up the stack. In fact, let's go back to our Wireshark packet capture that we did. This is where we left off in the last episode.
Love Wireshark.
Right? We talk about that frame information down there at the network interface layer. Notice you don't see the physical bytes, right? That's in the network interface layer, but that's the actual electrical currents that are leaving and coming into the network adapter. But we, again, it doesn't matter what frame type it is. TCP IP is just independent of that, right? So you can see our information here, right? We could see things like timing information, right? What time the frame arrived. And if we move up the stack, we could see that it's Ethernet 2. Right, and a part of that network interface layer is things like our MAC addresses, right? We can see the source MAC address versus the destination MAC address. In this case, it's my computer versus where it is going to, right? So we can see that source and destination MAC address here too, and inside of that frame. Just like in any encapsulation, if we dig down into this packet, we should be able to see some of the upper layer protocols, right? Because in the encapsulation, right, we've got all of those upper layer protocols up the protocol stack that have been handed down, and we now have a frame, which is our network interface layers protocol data unit, PDU, and it says that, hey, this is IP, it's using transmission control protocol, and it's using NetBIOS here, if you will, and then also that application layer protocol being SMB. So we can see that encapsulation right there. All of that information is right there in the frame. And then again, moving up the frame, up the stack, right? We get Ethernet, and what's where our source and destination MAC addresses are, and it tells us what the type of protocol is that we're moving down that stack, if you will. I know it kind of looks like up in the relationship to the way we're working here in Wireshark. We can see Internet Protocol version 4, right? This is where we talked about routing and addressing, right? And addressing being more specific to IP, right? And that's where we get things like, for instance, different service for like quality of service type information, right? Our DSCP, differentiated service code point, right? We can see that information in there, as well as moving up the stack again. Then we get to the transport layer, right? And we see transmission control protocol. We could also see some of those session ports, right? Port identifiers, including some of the session level services that we would typically see in what we call the OSI model, are all bundled here in the last layer, the topmost layer of the TCP IP model here. We've got also server message block, and again, negotiation request, right? So this application, this is a file access protocol at that application layer, like we were talking about, that's going to allow me to see, view, and exchange potentially data over the wire, right? So essentially what I'm doing here is I launched up our File Explorer. File Explorer is your Windows network or file and folder graphical user interface software, right? And it's an application. and it allows me to connect to the another computer, right, as well. So it's also it has to be a network aware application. So you can see that File Explorer is using an application layer protocol. Let me go ahead and close some of these layers here and kind of collapse them down on themselves. Basically, my File Explorer needs to connect to another computer. It's saying, okay, well, I need a protocol that's going to allow me access to the services within the network. Well, it uses SMB. SMB piggybacks on top of NetBIOS, doing a little bit of name resolution, if you will, or session message here too. And that is all in that application layer. Again, transmission control protocol, internet protocol, and the network interface. So you can see all of that good information inside of something like a protocol analyzer, which is why if you are studying for your Net Plus exam, look at some basics on how to use Wireshark. You don't have to, I mean, Wireshark is a very, very complex. They got an entire university dedicated. An entire course is dedicated to just this one piece of software, but you don't have to be that kind of type of expert. Right, we even got some Wireshark episodes in our course library. Jump over there and you can see just the basics on how to launch it up, right? And then start a capture so that you can actually see, hey, what's going on here, right? We can see the number of frames that are caught or captured, right? And we can, you know, with the protocol analyzer technologies, we can actually see what is going on in here. So great thing to have, and hopefully it helps out, especially when we talk about the TCP IP model. Now, we've been talking heavily about TCP IP model, right? In the first part of this episode, and I guess in the beginning of the second part here, we've also talked and got a whole entire episode that's dedicated to OSI. Let's go ahead and do something that we were told never to do, right? Let's cross the streams, right? Let's go ahead and compare the two. That's right, Zach. So I want to go ahead and I want to jump down to just a small little diagram that I have, and I know my head's probably going to cover up some of this, but for the most part, you should see everything, right? We have our layered model, two models, right? On the left-hand side of your screen, you have OSI. On the right-hand side of your screen, you have the Transmission Control Protocol, Internet Protocol, or TCP IP model, right? Well, what are some of the differences? Well, one of the biggest things that you're going to notice right away here is that we have what? We have what's known as a 7-layer model over here on the OSI side, right? So if we just count them off, we've got 7, 6, right, from top to bottom. We've got 5, and you probably know where this is going, right? All the way down to the physical layer here, which would be layer 1, right? And it is important to know OSI, but it's also important to know, and one of the reasons I want to take a second here and just kind of number them as we talk about them is because you might be on an exam purpose or an exam question where they're trying to ask you what layer you're communicating with, and I will tell you that it is very, very important, right, to know the different layers, right? And now you can see compared to, OSI or the TCP IP model, well, we only have 4 layers, right? And again, well, that's because there are clear definitions of what is going on in transmission control protocol, where OSI model, again, is a little bit more loosely defined, right? And when I say that, keep in mind, because there are certain protocols that we talk about that kind of operate on different levels, portion of it could be this level, and a portion of it could be this level in between, if you will. Really, it's clearly defined here in inside of transmission control protocol. All right. Now, so notice we have a 7-layer model, and we have a 4-layer model. So how does the comparison, what are some other things that we have to keep in mind? Well, keep in mind some of the things that we've already talked about, these two models, is that they were not jointly developed, but they were developed kind of in parallel, but between two completely different organizations, right? One was a worldwide organization, right? The International Organization of Standardization, the ISO, and another committee, and I cannot think of the name. It's more common that we just say ISO, but there was another committee, a European committee that was part of this too. So it was still a global effort, right? It's a worldwide effort. That's International Standards of Organization, has 126 different countries in it, right? So that's a little bit different than transmission control protocol, because how many countries were in TCP IP? 1. United States, right? Did you get that one there, Zach? I was going to throw him a curveball, but that's right, just one, right? We got the United States. And again, it was developed by our military going back to the 60s when they were heavily focused on ARPANET in those days, right? So again, even though they're layered systems, right, and even though they do define how communications are done, OSI model is not as optimized as TCP IP. right? TCP IP was made to route traffic across our major network today that we call the internet. All right, again, earlier days it was called ARPANET. Now, let's go ahead and talk about the functionality when we compare these two models together, because I do want you to understand that we still have a lot of the same functionality, but it's built into different locations, right? Let's go back to our slide here, and I've kind of got this color-coded in a way that you can see if we look at the OSI model. Right on the left-hand side, notice the color coordination here. You can see where the functionality is kind of drawn in or integrated into Transmission Control Protocol, Internet Protocol Suite, or TCP IP Suite, all right? Application layer, right? We say the OSI model application layer gives us access to the network services. Well, so does the application layer of the TCP IP model. Presentation layer, sometimes called the syntax layer, that's where formatting comes, that's where encoding happens, right? Formats our data in a way that the network doesn't have to do that. Well, guess what? That functionality is also built into the application layer of the TCP IP model. Session layer, we talk about, portions of TCP sit right here at this layer, right? And what do? Well, they help us to establish those connection-oriented services. Well, that session layer is actually built in to the application layer, all right? And I want you to understand that certain pieces of functionality of the session layer are also basically performed by the application layer of the TCP IP model. Now, one of the great things here, the next two layers, they're doing the identical things. Their names are different, but again, they're doing pretty much the same thing. Transport layer OSI model, transport layer of the TCP IP model, and I love when you can remember one thing for two completely different subjects, right? It makes it a little bit easier, a little bit less of that memorization, heavy lifting, if you will, that you have to do. Network layer, OSI, internet layer, if you will, over there on TCP IP. And this is where I want to call back to your attention. Remember I said internet layer? Think about why they would call it the internet layer, all right? If we aren't talking about routing traffic across dissimilar local area networks, we don't need the internet layer. We don't really need routers, right? If we're all on one massive network, right? We would just need the network interface, or in this case, OSI model, we would just need the data link layer and the physical layer, right? But that's not the way it is, right? We need to route traffic between different networks, and the way that happens is over the internet, right? Well, routing can happen internally across your networks too, but this is for more memorization techniques, right? The internet layer in the TCP IP model is what gives you access to the internet. It allows you to route traffic across networks, right? It's called the network layer inside of the OSI model, but functionality-wise, they're doing pretty much the same thing. Now, here's where it gets a little tricky, all right? You see the craziness on the OSI model, right? We're going crazy here. We got a data link layer. Data link layer is actually broke up into two sub-layers, one called 802.2, the logical link control. The other one's called the media access control. And we got the physical layer. Ooh, and we take a breath, right? Now, what do we have on the TCP IP side? We've got the network interface layer. My head's kind of covered it up here, but we got the network interface layer, right? And one of the great things is like I said, like Ethernet, well, OSI model, you have to remember Ethernet sits at portions of the data link layer as well as portions of the physical layer. Why? Well, we use MAC addresses. Ethernet uses MAC addresses. That is a data link layer switching technology, but it also defines the electrical capabilities and characteristics of the medium at the physical layer. How about we just take all of that and dump it right in the network interface layer, and it sits on a single layer. And that's what I mean by, say, optimized, right? There's not a lot of room right there. This is where you sit, right? You know exactly where your seat in class is, right? There's not really a gray area on that one, right? So definitely know those two. All right, so that is a little bit about some of the comparisons between the two. All right, if they ask you about the layers, I'm going to go ahead and move back one slide here because I do want you to keep in mind, all right? I've done this myself when I was communicating with somebody else and they were asking me about, they said, you know, layer 2, I need to route the traffic. And you can't route traffic with layer 2. Yes, you can. No, you can't. And then we found out we were both right. I was talking about OSI and he was talking about the TCP IP model. We were both right. When he said layer 2, what he was talking about was that network, that internet layer, where IP sits, right? Versus the network layer was what I was talking about, which I'm also right. So we were both right. All right. I want you to keep that in mind on an exam. What layer of the such and such model does a switch operate at? Well, layer 1 or layer 2. Well, there again, depends on what model you're talking about. If you're talking about OSI model, switching happens at layer 2. If you're talking about TCP IP model, it happens at layer 1. So you can get a little confusing. So know your numbers. That is an important thing. Know the comparisons. Know where some of the protocols sit, and also always pay attention to keywords. Because if you miss a keyword, just like I did, had I been listening to a friend of mine that we were discussing, switching, or it was routing, right? Had I listened to the keywords, I would have heard that maybe he was talking about TCP IP, or maybe if he had listened to me, I was talking about OSI model. But since we both thought we knew we were both right, which technically we kind of were, we didn't even agree to disagree, I guess, right? Mm-hmm. That little miss, right? Not only does it happen within just communicating amongst people, it can also happen if you don't read the question thoroughly. Read that question thoroughly. Pay attention to what model they're talking about. Know both of the models. Know the OSI model. Know the TCP IP model. Know the comparisons between the two. So just in case, all right, they ask you on the exam. But you also need to know this too, because as you go on to more higher level networking certifications, OSI model is going to be there. But you can believe the transmission control protocol, internet protocol model, TCP IP model is going to be there because it is the most common technology that we use to route traffic across the internet today.
Oh, well said, Wes. Very well done. And TCP IP Model Part 2, make sure you see Part 1 and see everything inside the Net Plus series as well, because Wes has done a great job putting that all together for you. And you're in the course library, so there's thousands of other videos there. Take a look at them. They're great for you, and they'll help you move forward. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Wes Bryan.
And we will see you soon.
Thank you for watching IT Pro TV.